So let's now look at a few examples of solving exponential equations. Now make sure you understand what makes this an exponential equation, other than the fact that the directions say it's an exponential equation. Whenever you're solving an equation, you're looking to solve for your variable. In this case, the variable is x. Now notice where it is located. It is located inside of an exponent, which makes this an exponential equation. So as we just said, in order to solve exponential equations, we want to begin by isolating the exponential quantity, the quantity that involves the exponent where our variable is located. In this case, the exponential quantity is 6 raised to the 3x power. So to get 6 raised to the 3x power on its own, we would begin by subtracting 10 from both sides of the equation. Why would we subtract 10? Well, subtracting 10 is the inverse operation of adding 10. It undoes this addition of 10. This gives us 6 raised to the 3x is equal to 37. Now that we have isolated the exponential quantity, to remove this 3x from the exponent, in other words, 3x is being exponentiated, we must do the inverse operation of exponentiation. And the inverse operation of exponentiation is logging. Now remember that whenever you log, you want to log using the same base as the base of the exponent. In this case, the base of the exponent is 6, which means we want to take log base 6 of both sides of the equation. Log base 6 of 6 raised to the 3x is equal to log base 6 of 37. Remember, algebra says whatever we do to the left-hand side of the equation, we must do to the right-hand side of the equation as well. So we just logged both sides of the equation with a base of 6. Now, why did we do that? Well, logging with a base of 6 is the inverse operation of exponentiating with a base of 6, meaning that these quantities here are going to cancel out and leave us with simply a 3x on the left-hand side of the equation. Logging with a base of 6 is the inverse operation of exponentiating with a base of 6. Remember, log base a of a raised to the blank equals that blank. In this case, we have a 3x. So we have 3x is equal to log base 6 of 37, and to solve for x, we are going to divide both sides of the equation by 3. Dividing by 3 is the inverse operation of multiplication by 3. Giving us our final answer, x is equal to log base 6 of 37 divided by 3. Now, you might be thinking this is an ugly answer, but really this is beautiful. It's nice and exact. Okay, don't worry about having logs in a final answer. That is perfectly acceptable. I must prefer exact answers. Don't give me decimal approximations unless the problem specifically says to do so. All right, let's look at another one. 8 times 3 raised to the 6 minus 2x minus 5 is equal to 43. Again, we want to start off by isolating the exponential quantity. Get the exponential quantity on its own. The exponential quantity in this case is 3 raised to the 6 minus 2x. Well, we are going to begin by adding 5 to both sides of the equation. Why do we add 5 to both sides of the equation? Well, adding 5 is the inverse operation of subtracting 5. It undoes that subtraction of 5. Next, we are going to divide both sides of the equation by 8. Why did we divide both sides of the equation by 8? Well, division is the inverse operation of multiplication. It undoes this multiplication by 8. Leaving us with 3 raised to the 6 minus 2x is equal to 6. Again, recognize our variable here, our x, is being exponentiated. It is being put into the exponent. And how do we undo exponentiation? Logging. And whenever we log, we want to log with the same base as the base of the exponent. Here, the base of the exponent is 3. And so we are going to take log base 3 of both sides. Log base 3 of 3 raised to the 6 minus 2x is equal to log base 3 of 6. Well, our inverse property says log base a of a raised to the blank equals that blank, right? Logging with a base of 3, an exponential quantity with a base of 3, those are inverse operations, meaning those quantities are going to cancel and leave us with 6 minus 2x is equal to log base 3 of 6. Now, to solve for x, we can begin by subtracting 6 from both sides, leaving us with negative 2x is equal to log base 3 of 6 minus 6. And to get our final answer here, we would divide both sides by negative 2. Again, dividing by negative 2 is the inverse operation of multiplying by negative 2. Leaving us with our final answer, x is equal to 3 minus log base 3 of 6 over 2. Now, you might notice what I did here. I took negative 6 and divided it by negative 2. That gave me a positive 3, and it's always nice to put those positive numbers first. So I have 3 minus log base 3 of 6 over 2. Again, distributive property of division says we have to divide everything on the right-hand side by negative 2. Reduce any fractions that you can. All right, let's look at another one here. E to the negative x squared is equal to e to the x squared minus 2x. Now, in this particular case, we have two exponential quantities with the same base set equal to each other. This actually means we can use the one-to-one property. Okay? Two exponential quantities with the same base will be equal if and only if their exponents are equal. In other words, negative x squared has to equal x squared minus 2x. Again, don't forget about the skills that we learned earlier on in the chapter. So, we just generated a quadratic equation. And as you guys all know, we solve quadratic equations by setting them to 0 and factoring. So, I can add x squared to both sides of the equation. That gives me 0 is equal to 2x squared minus 2x. And now we want to factor. Whenever you factor, first thing you want to look for is a greatest common factor, which in this case is 2x. We get 0 is equal to 2x times x minus 1. And setting each one of those factors equal to 0 gives us our solutions. 2 in this case, x equals 0, and x is equal to 1. All right, a couple more here. Solve the following exponential equations. All right, we're trying to isolate our variable x. And again, we need to start off by isolating the exponential quantity. The challenge here is that our exponential quantity is located in the denominator of a fraction. So in order to solve for it, we need to begin by getting it out of the denominator. We are going to multiply both sides of the equation by 1 plus e to the negative x. That gets rid of my fraction. I now have 400 is equal to 350 times 1 plus e to the negative x. Next, we can divide both sides by 350. Dividing by 350 is the inverse operation of multiplying by 350. 400 over 350, well, that reduces into 8 over 7 is equal to 1 plus e to the negative x. Again, I still need to isolate this exponential quantity e to the negative x, so I'm going to subtract 1 from both sides of the equation, or subtract 7 over 7. This gives me 1/7 is equal to e to the negative x. And now that we have isolated the exponential quantity, we can do the inverse operation of exponentiating with a base of e, which is logging with a base of e. Yes, we are going to take the natural log of both sides of the equation. The natural log of 1/7 is equal to the natural log of e to the negative x. And so here, the right-hand side of the equation is going to turn into negative x. Logging with the base of e and exponential quantity with the base of e, those are inverse operations, which will cancel each other out. Now, on the left-hand side, notice that we have division inside of a log. And we can use the properties of logarithms to expand that. This is the natural log of 1 minus the natural log of 7. So, why would we want to expand that? Well, the natural log of 1, okay? Anytime you see a 1 in a fraction, you might want to expand it because the natural log of 1, or log base a of 1, is always going to be 0. All right, so we can cancel that guy out. We have negative ln 7 is equal to negative x. And to solve for x, we multiply both sides of the equation by negative 1, giving us our final answer, x is equal to the natural log of 7. And one more example here. Here we have e to the 2x minus 5e to the x plus 6 is equal to 0. Now, this one is a little bit tricky. Notice that we have multiple exponential quantities, and I can't set them equal to each other on either side of the equation because I have this plus 6 in the way. All right, so that won't allow me to use the one-to-one property at all. So what we actually need to recognize here is that this is in the form of a quadratic, right? This is in the form of a quadratic, which means that we want to factor it. Yes, this is actually factorable. Now, when I say that this is in the form of a quadratic, we should recognize that this is the same thing as e to the x squared, right? Exponents raised to exponents, we multiply them. That would give me 2x minus 5 times e to the x plus 6 is equal to 0. And so because this is in the form of a quadratic, we can factor it. Now, if you're having a little bit of trouble trying to figure out how this is going to factor, you can think about what would this look like if instead of e to the x's, we just had x's. If we just had x's instead of e to the x's, it would be x squared minus 5x plus 6 equals 0. And what would this factor into? Well, this would factor into x minus 2 times x minus 3 is equal to 0. So this equation that is in a form of a quadratic is going to factor in a very similar manner, except instead of x's, what do we have? We have e to the x's. So this factors into e to the x minus 2 times e to the x minus 3. And just like with our regular quadratic equations, we want to set each one of the factors equal to 0. E to the x minus 2 is equal to 0, and e to the x minus 3 is equal to 0. This gives us two individual exponential equations that we can solve. Again, we can isolate the exponential quantity in each one of these. In this case, I would get e to the x minus 2. That gives me e to the x is equal to 2. In my second equation, I get e to the x is equal to 3. Now to solve, I need to undo this exponentiation. What's the inverse operation of exponentiation? That would be logging. I'm going to take the natural log of both sides. The natural log of e to the x is equal to the natural log of 2, giving me x is equal to the natural log of 2 here. And for my second portion, I have the natural log of e to the x is equal to the natural log of 3, giving me x is equal to the natural log of 3 for my final answer. So, two solutions for this quadratic. X is equal to ln 2, and x is equal to ln 3. There you have it, solving exponential equations.